Hi, grade 12s. So as I warned you in the previous video, I was probably going to run out of time on this particular example, but I did want to go and finish this example because there are some important things that I need to mention here in F and G. So as far as I can tell, I'm hoping it worked out that way. It did finish explaining E. I will just show you E again, just in case it didn't finish. So I'll start with E, and then I'll proceed into E, F, and G. So I apologize if you have to listen to E again. So again, it's number 4 from exercise 9.3, just finishing off from the previous video. So in E, they asked me, for which values of x will the second derivative be greater than 0? And I just want to mention that, saying, please remember, if the second derivative is greater than 0, it's where it's concave up. So concave up on the graph is over there. And in the previous one, we determined the point of inflection as that point 0, negative 2. So because it's that point 0, negative 2, the graph will be concave up from 0 to infinity. The graph will be concave up. So please don't use the negative 2. The negative 2 is the y value, and we want to know for which values of x. So answer to E, the graph will be concave up where x is greater than 0. Or you can also write it saying x is an element from 0 to infinity. There we go. So that is the answer to E. Then the answer to F then asks over here, write down the values of x for which the first derivative is greater than 0. Now please people, we have spoken about that first derivative when we spoke about increasing and decreasing functions. So we know first derivative is the gradient. Please people, remember it's the gradient. So it's where the gradient is greater than 0 or positive, so it's where the graph is increasing. So positive gradient or an increasing function. Now be careful with that one, because if you look at this graph, you'll notice it's increasing over here. So positive gradient increasing, then it gets to the turning point, then it's decreasing. So that's decreasing. Then it gets to another turning point, and then it starts increasing again. So I have that positive gradient. So if you want to answer this particular question, you will just go and you will look at the graph and you'll say, okay, for less than negative 1, it's going to be increasing. And then for greater than that a value, which we did calculate, so I'll just put that in here. The a value is the point, coordinates for the a is 1, negative 4. So starting there at 1 to infinity, it will then be increasing. Please people, these questions, do not calculate them algebraically. Not if you've done all of the hard work, you've got all the coordinates, and you've got the graph in front of you. So please do not do it algebraically, do it visually. So F, we're then going to say that the graph is increasing where x is less than negative 1 or where x is greater than 1. Now I can also do it in this notation where I say x is an element from negative infinity to negative 1 or from 1 to positive infinity. This is obviously the symbol for or. You should be aware of the fact that this is the symbol for or. Okay, so that was just visually answering this question. Then G, okay, now this is going to be slightly tricky, so you need to concentrate. Write down the values of x for which fx equal to k has only one root. Now, you guys still seem to struggle with this whole idea of roots. Now, first thing we need to establish is we need to establish the fact that the root here does not refer to the x-intercepts. And the reason the root does not refer to the x-intercept is because they have not gone and told me fx equal to 0, they've told me fx is equal to k. So if we talk about the roots when fx is equal to 0, then I'm talking about the x-intercepts. But if I'm talking about the roots, if fx is equal to k, then they are pretty much saying if I draw a horizontal line. So if I draw a horizontal line, and that horizontal line cuts this graph, then where do these graphs intersect? So because fx is equal to k talks about points of intersection between the cubic graph and a horizontal line, then we're talking about the roots being the points of intersection. So please remember the roots here are the points of intersection. Now, some of you might want to ask, but ma'am, how do I know this is a horizontal line? How do I know that? Because k represents a constant value. So if it represents a constant value, I can say k is the line y is equal to k. And you guys should remember that if y is equal to a constant value, it means my gradient is 0, so that is going to be a horizontal line. Please do not go and mistake this with turning points. I'm not saying that the gradient of fx is 0. I'm saying that the gradient of the straight line is equal to 0. Please don't mess that up. So these are going to be the points of intersection specifically between this horizontal line, and I'm going to use my ruler to indicate that horizontal line, and then the graph. Yes, the graph of fx. Okay, so now what they're asking is write down the values of x for which fx equal to k has only one root. So to have only one root, it means the horizontal line must only cut fx once. So if I drag this line over here, you'll notice there it cuts 1, 2, 3 times. And if I drag it down, 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 you will see over here it cuts 1, 2 times. If I drag it further down, you'll see over here it only cuts once. So that means I've got one root over there. Then if you drag it up, 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 then you'll see over there it cuts once, twice. But if I drag it further up, you'll see it cuts only once, which again says only one root. Now, I just want to change the question because this is in fact a typing error. Some of you might have already noticed it. It shouldn't say write down the values of x for which fx equal to k is only one root. It should say write down the values of k for which fx is equal to k has only one root. Otherwise, this question makes absolutely no sense. So we are trying to find out what value of k, so what horizontal line will mean that it only cuts once. And I've already shown you this. I've already shown you if the horizontal line drops below point A, it will only have one intercept, so one root. And again, if this horizontal line goes above that turning point, it will also only have one x-intercept over there. So my k value must then be located above that, and careful people, that means above 0. Not the -1, the 0. Because my k value says y is equal to k. So the moment I let that line go above 0, then my k value is then obviously going to be positive, and it will only have one point of intersection over here. And the moment I go and I drop it underneath this one, which again I'm going to refer to the y coordinate here, because remember y is equal to k. So if I drop it below -4, it will only cut once over there. And that is why I can then go and I can answer the question again visually. So visually answering the question, I can say k must be less than -4, or k must be greater than 0. Now, please note, I've not included, I didn't say greater than or equal to 0, I didn't say less than or equal to -4, because if I include these values, then you should see that if I go and I have the straight line y is equal to 0, so if the 0 is included, it still cuts 1, 2 places, which means 2 roots. I don't want 2 roots, I just want 1 root. And then over here as well, I can't include the -4, because if I include the -4, we're going to have 1, 2 points of intersection, so 2 roots. I want to only have that 1 root. So to have only the 1 root, my k value must be less than -4, or my k value must be greater than 0. So kind of a tough example, I'm fully aware of that, but we will obviously do more of these examples from past papers just to make sure you understand it properly. Thank you very much. Thank you for listening.